Right, this is required practical 3 where you have to produce a serial dilution, so dilution series, to produce a calibration curve, and we can use that to identify the water potential of a plant tissue. So what a dilution series is just a series of known concentrations, and from that you can plot a calibration curve. I've underlined in several places things like control variables. So for example, it's important to use a large potato tuber so that all of your potato chips can come from the same potato. The reason why that's important is because, well, first of all, control variable allows comparison, and then the second mark point for the potato would be that if you used a different potato, it'd have a different water potential inside, or a different sucrose concentration inside. So yeah, we're going to use sucrose for our series dilution. So with the practical, making the serial dilution, and that's here. So these are the different concentrations we need to make up. So a scale between 0 and 1 going up in equal intervals, so known concentrations. The table on the next page will show you how to work those out. So once we've got the serial dilution, we then need to get our potato. So we need to make sure that all the sucrose solutions are at the same temperature. Again, another control variable allows comparison, because if the tubes were at different temperatures, it would affect the rate of osmosis, because osmosis is practical. Again, other control variables, the potatoes have to be the same length, you have to let the chips dry, so two more control variables there. And another control variable here, you've got to leave the chips for 20 minutes in the boiling tubes before you record the final mass. So what you end up with, so this is how to do your serial dilution. So these were the concentrations of series of known concentrations we wanted to make up. And then to work out how much sucrose to put in each one, so 0.2 is 20% of the stock solution. So 20% as a decimal is 0.2 times by the volume we want to make up, which is 20 mils, 20 centimetres cubed. So 0.2 times 20, that means there's 4 centimetres cubed of sucrose needed. Again, you do that for each one. And then you add the amount of water so that each tube has the same volume of 20 centimetres cubed. You then need to, after you've done your series dilution, you've got your potatoes in for 20 minutes, you then need to draw a results table. So the independent variable in the first column, so concentration of sucrose, the unit should really have gone after the slash, so moles per decimeters cubed. So our known concentrations. The mass of the potato at the start, mass of the potato at the end, the change in mass, and the percentage change in mass. It's really important you have percentage change in mass because each of the potatoes would have had a different mass at the start. So this is what our calibration curve would look like. So we had our sucrose concentrations, and you should find in low concentrations of sucrose, so in this row here, that the chip gained mass. So we should have had a positive result there, because water will have moved into the potato. And as you increase the sucrose concentration, you'll start to notice that the masses become negative. So they've lost mass over time. So the results down here should be negative numbers, so that water has moved out of the potato. Because the sucrose concentration outside means there's a lower water potential outside the potato than inside. So the cells will lose water, become lighter. And how to work out the water potential inside your plant tissue, inside your potato, you have to find the point where the graph crosses the x-axis, where the line of best fit crosses the x-axis. That means that you've got a 0% change in mass, so then meaning the net movement of water in and out is 0, so no net movement of water in or out. So that must be the concentration of sucrose in the original potato. Just scroll through the questions you've had in your booklet and the mark scheme on the next page. Again, this is another example of a calibration curve where it crosses the x-axis, that is the salt concentration in the potato. Here we've got the mark schemes then for the questions. This is the value that crossed the x-axis.